One concept we're going to need is the idea of an isolated system. An isolated system is a system where the net forces are 0 newtons. So let's consider 3 examples. So this is my first example right here. We have little m and big M. Let's say those are the only 2 masses around, but I'm considering my system to be this dotted line. And so let me be clear about that. This is my system. So little m, if little m is a system, it's experiencing a force F of big M on little m. And so from the standpoint of little m being the system, the net external forces are not 0. So little m by itself is not isolated. On the other hand, if I take little m and big M together, assuming that there is nothing nearby, all other masses are, let's idealize things, infinitely far away. So these are the only 2 particles in the universe, let's pretend. If the system is little m plus big M, there are no external forces acting on the system. Yes, there is a force acting on little m, F of big M on little m, and there is a force acting on big M, F of little m on big M. But these 2 forces are internal forces, and in fact, if you sum these 2 forces by Newton's third law, they will cancel. So this is an isolated system. Let's consider a third example. Let's say you have a level frictionless surface, mu is equal to 0, and little m is going to the right with velocity v sub m, and big M is going to the left with velocity v sub big M. What happens when they collide with each other? Is this an isolated system or not? Well, first of all, you have to define what your system is. If the system is little m by itself, then during the collision, the banging together of little m and big M, what forces act on little m? Let's do a little free body diagram. And so during the collision, little m will experience a downward weight mg and a upward normal force, and it will experience a force to the left of big M on little m. And these 2 forces are going to cancel each other. So the net external force in the y direction is 0, but there is a force in the x direction which is not 0, and so little m by itself is not isolated. Similarly, you could make a force diagram for big M. Presumably its weight is bigger, and it's the normal force acting from the ground on it is going to be proportionately bigger. Something like that. It, however, will have a force to the right of little m on big M. These 2 forces are Newton's number 3 force pair, and so big M by itself is not isolated, because although the forces in the y direction cancel, the forces in the x direction do not. On the other hand, if we take little m and big M together, that is an isolated system, because in that case the y forces cancel on each one of the 2 masses, and the force of big M on little m to the left on little m, and little m on big M to the right on big M are internal forces, and they cancel, and so the net external forces of this as a system are 0, and it is therefore isolated.